Thanks for joining the webinar and welcome from TimesPro. So let's start off with the introduction of the today's speaker. And today we have got Professor Arpan Kumar Kar, professor and professor of from IIT Delhi. Professor Arpan Kar is currently the professor, full-time professor at IIT, that is IIT Delhi, and from Department of Management Studies and School of Artificial Intelligence. Uh, Within IIT Delhi, he holds a joint appointment between Department of Management Studies and also Yardi School of Artificial Intelligence. Administratively, he chairs corporate affairs and is a member of the Board of Academic Program and Advisory Committee for the overall curriculum development cell at IIT. His research and teaching interests are in the domain of data science, artificial intelligence, digital transformation, internet ecosystems, social media, and ICT-based public policy. He has supervised 12 doctoral students and over 75 master dissertations. In total, he has authored over 200 scientific publications and edited over 12 books. Among these, he has authored over 75 journal publications in established scientific journals and 14 publications in ABCDA journals. He has been cited over 11,000 times with an H index of 50 and I index of 138. Currently, he is the editor-in-chief of International Journal of Information Management Data Insights, published by Elsevier, which is the Q1 Journal of Data Science. He has also handled over 20 external funded research projects from national and international firms and comments like some of the firms and like BASF, Germany, Fidelity International UK, Department of Science and Technology, Government of India, World Bank, Bangladesh, Ministry of Electronics and IT, Government of India, Ministry of Tribal Affairs, Government of India, Ministry of Textiles, Government of India, and World Data Science Forum, Japan. He has also handled over 20 training programs within and outside India. He has given over 100 talks and keynotes in international conferences. He is also the research advisory board of different like Symbiosis University, XLRI, Jamshedpur. He has got to go on and on. He has got multiple achievements. So from a personal connect with Professor Arpan, he is very live on social media, that is on LinkedIn. So without wasting much time, over to you, Professor.
So thank you. Can I share my screen? I think I can then give the talk more easily.
Sure.
Okay, I'm sharing my screen and hope my screen is visible.
Yes, sir.
Okay. So a very interesting thing. So today we are talking about multiple slices of how data science is evolving. Today, when we are looking at how digital transformation is changing organizations. So what has started happening is there was, of course, a lot more digitization that initiatives happen. So the first wave of digitization initiatives started happening in the early 2000s. After the Y2K problem started happening, we started seeing a lot more enterprise systems coming in, and digital transformation started kicking in when we started having the cloud computing era. So the cloud computing era basically started sometimes in the 2010, 2012. And then slowly, because we had digital transformation across organization, many digital initiatives across organizations. So what started happening was we started seeing that there was a huge amount of data that is getting generated. And because this digital transformation touches about different users, different stakeholders of the society, governance, people who are always mobile. So there is a lot of scope that is coming across data science and decision sciences. So what started happening was whenever we started talking about, the digital transformation journey, there was a huge amount of data that was getting generated across organizations. So when organizations started getting into the digital journey, and that digital journey is something that has been expedited now because we started having a lot more technological interventions because COVID hit us. So organizations which were not digital started becoming more and more digital. So what started happening in this journey is that we had huge amount of data coming in from Web 4.0 services. Like today we have social media, we have the next generation social media, which would be the metaverse coming in, then industrial 4.0, which is typically the fourth industrial revolution coming in, a lot more IoT, Internet of Things devices, a lot more digital services, a lot of transactions which are happening, biometrics coming in. Then we have a lot more communication which are happening, whether it is through platforms like social media like Facebook, or whether it is through platforms like, say, WhatsApp. Because of these platforms, what is happening is a huge amount of data is getting generated. And because this data is getting generated, firms are now able to use this data for gaining actionable insights. And they are able to leverage this data for, doing a lot more value addition to the organization. So in this journey, what started happening was, initially, if you look at how the data started exploding, typically the data has been exploding at the rate of 50 times over a period of 10 years, which basically means that every year you would be having more than double of the data coming in. So whatever data is getting created through, high volumes, very high velocity, very high variety, because today data is in the form of, kind of unstructured data in videos. You have Instagram videos, you have text messages in WhatsApp. It is very easy to, extract information out of, say, social media platforms using APIs from Facebook and Twitter, or using the extraction features in WhatsApp groups, and then make meaning out of it. And then firms can make meaning out of it. But what is the challenge is this data has lots of noise. So how do firms make meaning out of this huge amount of data, which will typically be, very, very high volume, high intensity, high variety. These attributes are typically demonstrated, which are typically called as the 4V characteristics of big data. And this is where basically all these firms need to have mechanisms of addressing these needs of organizations. They need to have mechanisms in which they're able to use this Web 3.0 data, the machine to machine data, the huge volumes of transactions which are happening on platforms like Amazon, Flipkart, Big Basket, biometrics coming in, the communication data which is coming in through WhatsApp. How do firms address this? And this is basically the area that is emerging, which is called as data science today. And we are used to seeing a lot more, elements of artificial intelligence and machine learning coming into this. So in this data science evolution, at the early stage, if you look at it, how firms were typically carving value, initially they were mainly focusing on cleaning the data, ensuring data quality, and then came elements like descriptive analytics and diagnostic analytics in most of the firms. And then these were the kind of analysis that was typically done when we had siloed system in the 1990s and in the 2000s. Then came the era of artificial intelligence, when we started seeing on one side predictive analysis, which is mostly in the data science vertical, and of course in the decision science vertical, a lot more prescriptive analytics started coming in. So the prescriptive analytics would bring in simulation and optimization systems, and the predictive analytics would typically bring in a lot more of artificial intelligence and machine learning. So these were where most of the generations of how AI started coming in, how organizations started using AI, and how they started leveraging these data capabilities. And today, when we are talking about data, we always say that data is the new fuel, data is the new oil. And people who are skilled in data, they are going to be the next set of employees who are going to be valuable for organizations. This was the trend. And then things again changed. Things changed because we started having the cognitive sciences or the semantic analytics coming in. We started seeing that platforms like social media are making meaning out of unstructured data. YouTube videos are making meaning out of the unstructured data that is there in the user generated content, that is there in the inferences. Then we started having in the cognitive analytics or the semantic analytics, things like ChatGPT coming in, generative AI coming in, and there are different kinds of large language models which start making meaning out of semantic data. So the data scientist role is also evolving. The data scientist role, which was more focused on predictive and prescriptive analytics, maybe 5, 7 years back, now we're seeing a change that in the next 5, 7 years, there'll be a huge focus on semantic and cognitive analytics, things like social media analytics, things like text mining, natural language processing, then image mining, computer vision. These are going to be the areas which will see a lot of growth. So, what has changed? Earlier, if you have to go in the history of how data science started, it's not something, it is something very, very new. There was three different disciplines. On one side, we had understanding about artificial intelligence and machine learning. Then on the other side, there was knowledge in the statistical analysis methods. And the third side had knowledge surrounding operational research. What was realized was that these knowledge areas were typically coming in from different disciplines altogether, and they never started interacting with each other. Statistical analysis and AI/ML, these two disciplines had somewhat some degree of connection, some degree of interactions. But the other disciplines which were there, like when we talk of decision sciences, typically the decision sciences discipline would come from industrial engineering. So when we are talking of industrial engineering, things like manufacturing sector, we are talking today things about Industry 4.0, the fourth industrial revolution, manufacturing, mining, even the logistics sector, they're heavily using these decision sciences model. The other side of things are coming in from the computer science model, and typically people who are trained in computer science, electronics, electrical engineering, they would typically have some background of machine learning, artificial intelligence. They are able to understand some elements of nature-inspired computing, bio-inspired computing, things like social media analytics, things like graph theory. So they are trained in this. But what was missing was the people who were coming in from social sciences, they would only be understanding about methods which are coming in from areas like regressional analysis, factor analysis, econometrics, ANOVA, MANOVA, time series analysis. These knowledge areas were different. These knowledge areas were different, and people never tried to combine these things. But now, when we're talking about the new age requirements, what firms need, firms do not need a person who is trained in only one silo. Firms need a person who is skilled in across multiple of these areas. So data science and decision science as a holistic area started growing in. People who were coming in from industrial engineering, they started also exploring algorithms, which were coming in from computer science, and they started combining those algorithms with methods like econometrics and ANOVA, MANOVA, and so on. Similarly, people who are kind of skilled in the area of computer science, they started exploring things like social media analytics, natural language processing. And when they started using things like natural language processing for inferential analysis, for explaining why certain things are happening, what is the element in the data that is giving some insight, which is not really that much understandable otherwise. So they started dabbling with areas like the econometrics, because that helps you to give causal inferences. That starts giving causal inferences. So because of this, what started happening was the disciplines which were typically in silos, and these disciplines are things like, suppose I have to talk of a traveling salesman problem. Say an example is, suppose you have given an order in Amazon. So Amazon, the person who's going to make a delivery from Amazon today needs to visit, say, 20 different locations. What should be the sequence of location through which his traveling time and his traveling, kilometers are basically minimized? These are typically traditional, industrial engineering or operational research or decision sciences problem. But these problems become very complex if you handle them using the traditional methods. So computer scientists started seeing that, okay, this is a very complex problem. Is there a mechanism I can deploy machine learning algorithms on it, artificial intelligence algorithms on it? And they started deploying the AI algorithm, the ML algorithm on complex problems, which started getting more and more complex because there was a point of time an Amazon person would probably have 5 deliveries to make in a day. Today, there may be 5 million deliveries being made in Delhi only. So when you have 5 million deliveries, which deliveries to be allocated to which, delivery person, and the delivery person who is having 20 deliveries or 30 deliveries in a day, which is the sequence of houses that he should be visiting to complete the deliveries. So this become complex problem. To solve this problem, ML started getting more and more popular. There were new kinds of ML which started emerging, and ML is not something very new, but it started emerging. And so people started looking at how they can solve this decision sciences problem using ML and data science. So data science as a huge area started gaining more and more prominence as more and more people started looking at how they can leverage upon the skills of data scientists in organizations. Earlier, data science was only restricted to organizations which were predominantly in the IT services industry. Now it is no longer going to be the case. Data science skills and decision sciences skills, or rather data skills are going to be pervasive. Organizations which are not in technology sphere also, they need people who can use this technology. They can use these tools and use data to make better decisions in the organization. This is where basically all the things are evolving. So what we are seeing is the evolution started with supervised learning, moved on to things like unsupervised learning. Then there are newer models which are coming in, like reinforcement machine learning, federated machine learning. But more or so, most of the examples in the industry today are related to supervised and unsupervised machine learning. But when we're talking about the supervised and unsupervised machine learning, there are newer elements of approaches which are being used these days, things like clustering, classification, regressional analysis, sequence mining, summarization, anomaly detection, network mining. These are the new things which are emerging. And because how these new things are emerging is at a pace which was unprecedented, it is becoming extremely difficult for people, for employees of organizations to catch up, to learn these things in an ocean of knowledge. Earlier, there was a point of time where it was very easy, you know, to know certain things because knowledge was restricted. The challenge was access to that knowledge. The challenge was access to that knowledge because at that point of time, the number of books, the number of research papers in any particular discipline used to be much smaller, used to be much lesser. Now there's an explosion. An explosion of knowledge has happened in the last 5, 10 years. The bigger challenge now is segregating what is information and what is misinformation because everything is available freely online. You go to the YouTube, you see videos of machine learning. You go to blogs, you will see descriptions of machine learning algorithms. You see descriptions of data science. But what is problematic is a lot of these concepts which people are talking about is often not scientific based. A lot of these concepts people write in blogs because it does not require any kind of peer reviewed process. Experts don't have to kind of vet whether this is really the right thing to do or not. People have started putting in a lot more information online, and this is creating what we call today WhatsApp University or Google universities, which have spread a lot more misinformation today. So it is very important to understand which are the correct sources of information, where can you get adequate, correct mechanisms of knowing these subjects. So if you look at how these disciplines kind of evolved, these disciplines started in the 1970s, or even earlier, if you talk of machine learning, it started in the 1950s. And then at that point of time, Alan Turing basically brought out the Turing test, and he basically proposed that, okay, one day, algorithms, which are made out of mathematical formulations, they would be able to think like a normal human being. They would be able to kind of replicate the way natural intelligence works. In that, how does natural intelligence work? So for that, there were algorithms which started in the 1970s, and today we are talking about them in a huge way. Things like neural network came, then came genetic algorithm, then came leaping frog algorithm, then came ant colony optimization. And these were all algorithms which were looking at the way that nature typically operates. And nature operates in a particular way and there are certain principles of Darwinism theory that typically nature propose. So what happens is we try to look at food, we try to search for food, we try to ensure that the reproduction happens so that the next generation is better, the next generation carries on. These principles of Darwinism started getting embodied in the way that data was getting analyzed. It started a new generation of race for artificial intelligence capabilities, and things like bio-inspired computing, nature-inspired computing became more and more popular, became more and more famous, and people started developing capabilities in these areas. So in this, there are certain things which have been going on for a long time, but industry has just started picking them up. What has happened is, for example, when we talk of the older models, there are newer models of algorithms which are emerging, but there was also another debate. One of the important debates which has started today is basically called as the future of work debate. The future of work was something that was brought out by World Economic Forum. And today, when we are talking of future of work, even Gartner proposes that future of work is going to, kind of come in the way that we are operating. We are working in organizations in a big way. So what will happen in the future of work is a large part of the workforce is going to face the challenge of acquiring new skills. If they're not acquiring new skills, and most of those skills are hard skills as well as soft skills, a combination of hard skills and soft skills. Now, if you're being recruited for your hard skills, you need to maintain soft skills so that you are able to thrive in the economy. So to get employed, to get into a position where you're hired for your hard skills, you need to gain certain tangible knowledge across multiple areas. So many of these things are related to how to understand data, how to use artificial intelligence, how to create a decent understanding about machine learning. And this is where basically it gets more and more challenging because a human being typically has a career spanning 30 to 40 years. Now, in that 30 to 40 years, earlier, the expectation was that one can learn new capabilities, learn new skills, unlearn them, reskill themselves maybe 3 or 4 times in that career, which basically meant that every 8 years you start planning for picking up a new skill. But now no longer it is true. Now that skilling, the reskilling and the upskilling needs to happen more frequently. So every 3, 4 years, if you're not getting reskilled, the challenges what are happening is that people are going to be obsolete in the industry because a lot more automation are going to take away jobs which are going to be very easily replicable and replicable by algorithms. Human intervention may not be needed. The enterprise system, the ERP system would have a lot more AI, a lot more of these ML systems, agent-based systems, which will typically take away a lot more of the jobs, which are typically done by human beings right now. But over the next 5 years, these jobs will be automated, and there would be new job descriptions which are going to be emerging. So we need to have a workforce which is going to be ready for the future with this new technology, new skills, and be able to use data. They will be able to use data in such a way that they can do justice to their roles in a very different manner. So in this, how this evolution is happening was earlier we looked at, say in the 1950s, we started talking about concepts of artificial intelligence. Then the concepts of machine learning started coming in the 1990s with companies like Walmart when they started, doing things like market basket analysis, things like suppose you go to the store, you added something in your basket, then what else do you keep besides, say, the stack of or the rack of bread? Do you keep eggs or do you keep maybe a washing powder? How do you decide what to keep after each other? So those kind of analysis, those kind of data analysis using machine learning started in the late 1990s and picked up in the early 2000s. Then came the era of Amazon when this market basket analysis became recommender systems. So the recommender system starts recommending you, okay, you have looked at this news or you have looked at this movie in Netflix. People who watched this movie were also interested in another movie. People who had looked at this particular news were also interested in different other news. So the machine learning era came in. Then came the next era, that is the deep learning era, which was again neural networks, but there were different models of neural networks coming in. The deep learning era basically started making meaning out of images. The focus of the deep learning era was to make meaning out of images. So suppose you have your Facebook face profile, and based on the profile image, Facebook starts making meaning that, okay, you are a person with a particular socio-demographic. Based on the images that you're uploading, which you're clicking on your phone, Facebook starts creating a socio-demographic profile about you, a segment about you. How do you make meaning out of images so that you are able to create segments? Then came the next era, the current era that we are right now in, which is basically generative AI. When we're talking about things like large language models, things like how people can leverage upon large language models. On one side, there would be people who would be developing large language models, and there would be people or a career line who need not understand how to technically develop large language models, but they would be skilled in prompt engineering. They know what kind of prompts to be given to the generative AI so that the generative AI can give you back responses which will reduce the time taken to undertake any job. So, how do you use AI in such a way that the normal job which had some elements of creativity, some elements of information search, some elements of design decisions, how can you do all that in a faster way? So newer elements of machine learning started coming in, and all of these are machine learning and artificial intelligence. But just that newer models started emerging in which careers like prompt engineering became popular. People who need not understand the engineering side of artificial intelligence, but people who know what artificial intelligence broadly is and will be able to use artificial intelligence. For example, when you're talking about your smartphone, you need not be an electronics engineer. You need not know fabrication of how motherboards are fabricated in that smartphone to be able to use it. Similarly, somebody who is going to use generative AI need not understand the nuances of the mathematics which is going behind the generative AI, but then they should be able to understand how to use artificial intelligence in their work so that the productivity is improved, so that they are able to be more efficient in their workplace. So, what is happening is gradually these technologies, these algorithms of artificial intelligence and machine learning, data science, these skills are moving from becoming a differentiator for people in jobs to become something that they need to do so that they can sustain in their jobs. It is a basic infrastructural asset. Like today, there was a point of time, if you talk about 50 years back, when the industrial revolution came, steam engine, electricity, they were differentiating, skills, they were differentiating resources. Today, every organization needs electricity. Similarly, when the computer revolution started, it was a differentiating skill. If you knew how to use a computer in the 1990s, you got your promotions faster because it was a differentiating skill. But today, it's no longer the same case. Today, if you know how to use a computer, that's something that every child knows. Today, your son, your daughters would know, even if they're in class 4, 5, or class 2, how to use a computer. So, what started happening was the ability started getting recognized that you need to know how to use technology. You need to know how to use the technology, not even build it for other job roles. So of course, there is a lot of people who would be, who would be very, very useful, who would be able to use and build technologies like generative AI. That sort of skill set, people are investing, say, 7 years, 5 years in a PhD program to get skilled in that area. The other side of skilling is basically people who are not technology that savvy, but they need to understand how to use data. They need to understand how to use these AI platforms. They need to understand how to use prompt engineering so that they can be more efficient, they can be more effective in their business as usual workforce. So, this is the change that's happening. And there are many other challenges which are coming up for people who are working in the research space. To what extent you can create readiness for using these technologies? To what extent you can create differentiation? How do you address elements like information security and risk? Because we're talking about huge amount of data. How do you preserve the privacy of people? Because today, when we are using social media, all our actions can get tracked. And then, if all the actions are tracked, you can build personality models about everybody. It is possible to understand, okay, you're a person who is going to vote for a particular political party. You're a person who is likely to have certain kind of social, demographic equity. You're a person who has certain kind of trust on other peers who are interacting with you. So there is a lot more challenges of preserving this privacy. Things like challenges surrounding reskilling, deskilling, how you can move towards entrepreneurship ventures when majority of the workforce is getting defragmented, how to deal with different kind of governance and policies surrounding AI. All these things are gradually becoming more and more important. So in this journey, what is happening is we are seeing a lot more changes, huge amount of turbulence, a lot of opportunities which are also coming in surrounding things like human in the loop, things like how job losses are going to happen because AI is not going to be used or adopted easily by all the organization. What kind of biases can be there in AI? How can you protect AI systems from having biases? There was a days of Terminator when AI was conceptualized as being something that may not even happen. But now we are seeing that AI is actually happening and AI is percolating, AI is pervasive, AI is changing the way that we are interacting with any devices, whether it is platforms like EdTech, whether it is using a smartphone, whether it is using social media, whether it is using Amazon, whether it is using Big Basket, AI is going everywhere. And this is where basically it becomes more and more challenging for us to understand and upskill ourselves into the different sides of AI. So there are many challenges, understanding the right questions, understanding what data needs to be captured, because these systems of data science, decision science are driven by data. If you capture the right data, if you have the right methods of data extraction, the right models for data analysis, and then how do you interpret the outputs of this analysis? That's also a big challenge because a lot of times people know how to do certain visualization. People know, okay, I put the data in Tableau, a nice visual output is coming out. I put the data in some kind of ML platforms. I do some visualization using Python. The visualization is exciting, but what does it give me? How do I interpret it? I get some statistical output. What do I make meaning out of that statistical output? What is the value of that R squared that I get in a regression equation? What is the meaning of that p value in a statistics that we're getting? What is the difference between a sample and the population? To what extent I can generalize my sample reports to the entire population? Those kind of questions are coming in. On one side, there are people who are on the right hand side, who are typically functional people, people who have a lot of domain knowledge. Their need is going to be that they should understand how the analysis was done, what methods for analysis was done, and what are the challenges of interpreting those methods. And the other side of the thing is that you have people who would need to collect the data. They would need to collect the data. They would need mechanisms of analysis of the data. And then subsequently, they would need to kind of work on the data using different algorithms. How do we address this? These are the challenges which are happening today, and because of which we are seeing a huge amount of turbulence in terms of understanding this entire area of data and decision sciences. So with this, I'll stop. I'll be happy to take any questions. So Sahil has questions surrounding data science for tourism project. You want to understand the views of data science as a distinct field of study which provides new epistemological tools and techniques for tourism and hospitality related research. I'm particularly interested in theorizing or conceptualizing data science for tourism, so that I like to inquire about how to embark on this journey. Okay, the other side of the question is I'm curious about the scope of pursuing a postdoc in the area. Okay, so when we are talking about data science and tourism, things like tourism is just another service. So if you look at tourism literature, it's basically a service science literature. So when you're talking of tourism, what happens is today we are talking of different slices of digital tourism. How can we, you know, things like virtual tourism are coming in today when we are talking of augmented reality, virtual reality. A lot of tourists would be having questions, queries, interactions with services through devices like, for example, extended reality. Then people are sharing their experiences. You visit a place, you start sharing your experiences about the place, either through feedback on platforms like Make My Trip, or you start sharing your feedback on platforms like Facebook or Twitter. So that user generated content, which is there, that has started creating huge amount of information, huge amount of knowledge surrounding how user experiences are getting shaped in their service encounters. So when we are talking for tourism research, we publish few papers. You can look at it, Sahil, that today when we're talking about tourism research, a lot of papers of ours, I think about 3, 4 projects of ours, especially there was one project which was funded by Department of Science and Technology. It was mainly to give inputs to the Ministry of Tourism, how tourism services should evolve, what kind of parameters should be there in tourism services so that the service encounter, the service usage experiences can be improved. So a lot more methods of data science, natural language processing, models of decision sciences come in if you are going to create models which will be verifiable, if you're going to create models which will have a lot more positive impacts on the different user groups. So with that, what will happen is over the years, there'll be newer models of tourism which will come in, which will not be typically based on survey based or questionnaire based kind of data. They will not be validated by questionnaire kind of data, but those models will be validated by trace data which will be there in different platforms like Reddit, Make My Trip, or hotels.com. That's where basically the data science comes in, that these platforms like Make My Trip Data Science can use data science. These platforms like hotels.com, then tourism ministry, they can create mechanisms of intervention to improve the services of individual tourist. So the next question is from Krishna Jyotish. Hope I have been able to answer the question of tourism from Sahil Sharma. The next one is a question by, can we do any freelancing job by learning tourism? So if you look at tourism, if you look at data science jobs, there are certain data science platforms. So if you look at data science freelance platforms, one platform of Wipro comes to my mind immediately, which is called Top Coder. So if you learn data science, things like data science and decision science, and then you can offer your skills as a freelancer in these platforms. You show your certificates, you show your projects, you showcase your, say, capstone projects, you showcase your learnings, and then you can bid for projects in these platforms. So as a freelancer, some of these platforms like Top Coder, some of these platforms which have come in, like I was consulting for one Japanese platform, which was basically World Data Science Forum. They created a platform called BitGrid in which different codes would run. So the data science codes would run on this BitGrid platform, and this BitGrid platform would allow different users to use the code. Now, when a user is using the code, using blockchain, they would trace that, okay, this particular platform is using the code, this particular organization is using the code. So the payment will be attributed back to the person who has created the code. So there was the attribution that would automatically happen because of this training, because of how he would develop something, an equity which others could also use. So there is a lot of freelancing opportunity which happens. But normally what I've seen is people try to move towards jobs. First of all, when they do the course on data science and decision science from IIT Delhi, typically what I see is they try to move towards jobs, first of all, shift their roles within the data science and decision sciences roles within the organization they are working into, and then shift outside the organization. First, they try an internal shift and they try a external organization change. Hope that answers your question, Krishna. Third is Anilesh Mukherjee. What type of courses do you suggest for a non-technical experienced person? It's quite interesting. See, when we are talking about data science, one cohort of courses, I mean, there can be no single course for non-technical people. You will have courses where some elements of technology will come in. So if you are trained in, say, purely non-technical, non-quantitative subjects, like suppose you have a background in sociology or psychology, it might be a little difficult, not impossible, but difficult for you to move towards data science. But when you do a course in data science, what will happen is you will start understanding different new skills. You will start be able to use some of the methods in your job description. But most of the time, we do not really need a computer scientist to be a data scientist. Of course, there are some certain skills, building ML models, building, algorithms. They would typically be people who are doing a PhD in, say, for example, with me, there are some 10, 12 PhD scholars. They are actually building models. So that's a different thing. They're investing 5 to 7 years to develop that skill. Throughout their academic background, they've done their BTech, MTech in computer science or IT. That's a different kind of role. For others, they should be in a position to be able to understand and interpret basic mathematics at the level of class 12. If they are comfortable with maths at the level of class 12, then they can learn, courses like, for example, in IIT, we offer this course on data science and decision sciences. You can go for such a course, which is not purely technical because today there are lots of code generators. You just type in your prompt, the system generates the code that you need to use. But you need to understand basic maths and what a particular model is capable of. That particular algorithm, this is an algorithm which acts like a hammer, so you can use it on a nail. This is an algorithm which acts on a screwdriver, and you can use it with a screw. You should not use a hammer with a screw. You should not use a screwdriver with a nail. Those differentiation is needed. The next question is from Garima Jain. How to get into a data analyst job in a technology shift in a career? Everyone is looking for experienced people. Having 10 years of industry experience, but not in data analysis is not helping getting into this field professionally. Garima, this is quite a big challenge. So when you are having these different skills which are coming in, and you are doing some courses like data and decision sciences, how you learn, what you learn in the course is always going to be one part of it. One part of it, as in, it gives you certain basic skills. Now, what you do with those skills, to what extent you are investing your time in doing a capstone project extremely seriously. If you start doing some freelancing job with some startup and do that very seriously, and then you can showcase those as projects. Some part of your work experience which is related to a domain, say you have a domain like vertical, like say financial services, you understand the ins and outs of financial services. Or you have a domain, you're working in a discipline like say transportation services, so you understand everything about the logistics industry. So your incoming, your contribution or your expertise is basically a person who understands the rules of the logistics industry, or he understands the rules of the financial industry, and also can talk with people, and also can do data analysis, and can understand what a computer scientist is expected to do. So you should be able to merge these skill sets together once you do these programs and when you complete these programs. That being said, you cannot expect that once you are 10 years in a particular discipline, working in a particular discipline, you get the same treatment as another person who had been a data scientist for 10 years. Your data science skills are still at an elementary level. You need to showcase that over a period of time. You would be able to leverage upon the first experience, give it a dip, give it a discount, but you are able to leverage upon the data skills, the data related skills as well. And then you are able to grow. once you start demonstrations. So that's what typically you need to do. The next question is from Manj Sharma. How data science can help in auditing and accounting? In fact, this is one of the industry that is going to get hugely affected because almost all of auditing and accounting is based out of rules. Any industry which is heavily based out of rules, they can be automated. So data science and AI is going to automate a lot of the work that typically, I'll say CAs and cost accountants are going to do. So if CAs and cost accountants don't understand how to, enhance their productivity, improve their own understanding of these tools, then they are going to go out. This is one industry which has been kind of, it is being foreseen. There is a lot of reports from World Economic Forum, reports from Gartner, which says that, these are neutral bodies. I'm not talking about the reports from IBM or HP, which says that accounting profession is going to die out unless they learn these skills. I'm talking about World Economic Forum, Gartner, which are non-IT companies. They're also saying that these particular industries, which are very rule-driven, which are very, process-centric and they're rule-driven, they are going to face challenges unless they start embracing it. The next question, how much time it will take to learn and start a freelancing job in DAs? I would say that typically go for courses which are longer duration. And after you complete the courses, also start picking up different data sets that the course will allow you to give access and start analyzing that. Try to develop a couple of maybe conference papers or maybe a patent and demonstrate that you know about the area. Patent is a little challenging, but because it takes time. But I would say that you start doing some couple of conference papers to demonstrate you know about this area, create that intrinsic bullet points in your CV, which shows that you have adequate understanding about data science. You have adequate understanding of machine learning. Then you can apply for jobs. See, if you start applying for freelancing projects, people who will look at your application, they'll also try to understand what kind of background you have. Do you have demonstration of working on those algorithms? Do you know what each algorithm is? Do you have some publication in those algorithms? Some intangible elements which will signal your competency is needed. So some people can build that competency in 3 months. Some people will struggle to build that competency in 3 years. You need to figure out where you are actually positioned. The next question is from Saurav Ghoshal. And Saurav, I have a question. What should be the learning path for an AI functional user of ChatGPT to ready himself? So, see, typically all of us are using search engines. Search engines are also AI, they also use AI at the background. We know how to use search engines. Now, the question is, do you just want to be a user of search engines or do you also understand some elements of how search engines are designed to be useful, to be really, you know, good at your work? You need to understand some elements of how search engines are also designed. So you should be able to understand a little bit of how generative AI or ChatGPT systems are designed, what kind of input it gives, what kind of output it gives, what kind of answers it will give with a higher accuracy, and which kind of answers it cannot give. The boundary condition in which these platforms like ChatGPT operate, you need to understand that. So that will help you, better at your job. Do certain courses on data sciences, do certain courses on decision sciences. Like for IIT, when we run these courses on data and decision sciences, these are heavily subsidized. I mean, a typical course like that, 150-hour course like data decision science would go for, like in private schools, it will typically go for 4 5 lakhs, 6 lakhs, or financially independent institutes like IIMs, it will go for 4 5 lakhs, but we offer those courses at a much cheaper price because it is heavily subsidized and IITs are, kind of subsidized by government across its education. So if you can go for, courses, it will be helpful for you, to understand this area, get little bit of hand holding, and depending upon how much efforts you're putting in, you'll be able to upskill yourself in this area. The next question, how AI can be used by finance people, how AI can be integrated in small businesses. I think AI is gradually being used by a lot more people in finance for For example, these companies like American Express, companies like banks, they are using finance for financial management, for predicting frauds, for predicting credit risk. There is a huge amount of AI which is being used. So we use a lot of case studies in our classes. We talk about the projects that we are doing. For example, I'm doing a credit management project with a company called BASF, which is a Fortune company. We are trying to basically build an ML model or an AI model to understand when to give credit, when to not. So these are basically areas in which finance and AI is getting integrated. So entire courses these days are talking about not AI in isolation, but how AI can be used in business. AI in isolation has been happening for a very long time. People developed a lot more algorithms of AI. Now, what is happening is in the last 5 years, all this hype about AI is because the business is seeing a lot more use cases. The business are seeing how they are able to adopt AI in their systems. That's where all this traction is coming. So, how can data science help in terms of auditing and accounting? I think I answered that. Uh, I've been answering, I think I've answered more or less all the questions. So, Amjad, the question that you're asking that those who know little English and mathematics should take admission in this course or not? Yes. It depends on the level of mathematics. If you have done mathematics till class 12 and you are fairly okay with that level of mathematics, then you can take admission in this course. But if we are looking for people predominantly in the graduation who have had some elements of some slices of engineering, could be across different disciplines of engineering, or have studied about physics, maths, science, economics, because these are little quantitative subjects. But if you had joined a different disciplines in your graduation, which was not very computational, but you can still apply. We will have to interact with you to understand whether like you would be suitable for the course or not. We also would not take you in unless you would be able to cope up. That is one thing that whoever applies to this course, we do not take them in. We do an interaction. We try to assess the person's CV, the person's aptitude, whether he'll be able to cope up with the course or not. So you should apply, and then we have to basically see that, okay, is your quantitative aptitude, is your mathematical aptitude good enough to do a course on data science and IT Delhi on? With this, I think I've tried to answer everything. If you have a career gap, will it create a problem to join in data science? See, depends on the extent of your career gap. So if you have a career gap of couple of years and you start doing a program, I think that will be fairly okay, because a lot more people lost their jobs when COVID happened, because that period was when a lot more turbulence happened. So getting back to a job, HRs are fairly able to understand that, okay, there is a career gap because of certain disruption which happened across the globe. That is not really a problem. But if you're talking of a career gap, which is maybe 7, 8 years, maybe it will be difficult for you to, join in a organization which is very large, having lots of structured processes and HR principles. Maybe you can start off in joining a startup, because startups have a little bit of resource crunch. They look for capabilities of people who are able to solve problems and necessarily not come from a background and from a role, because they're not able to pay that much. But you start in a startup and then you can switch into a larger organization. I think that should be the strategy that you should follow. I think with that, I answered all the questions. If you want to reach out to me for anything, feel free to reach out to me in my LinkedIn. I'm fairly accessible in LinkedIn, so you can reach out to me in LinkedIn. And if you join the course, of course, if you're selected for the course, you apply and you're selected. In that case, we'll definitely be interacting a lot more. I'll be happy to take any questions further. Thank you. So you can connect with me in LinkedIn if you're not already connected. I see a lot of people, I think, who are already connected with LinkedIn. So you can connect with me and I'd be happy to take any questions. Thank you.
Any questions, guys? If you have, then you can post. Yeah, I think so. We don't have any questions. So thanks, Professor, for the nice talk on the topic. And you have already informed them to connect on LinkedIn. So if you have any questions, you can connect with Professor on LinkedIn and ask that particular relevant doubt. And thanks, Professor, for this valuable session, sparing your valuable time and giving the learners the insight about data science. Thanks a lot.
Thank you. Thank you, sir.